Welcome back to the next lesson, grade 9s. We are going to talk about compounds and how to use Lewis structures to show how the compounds are formed. So what are compounds? The definition of a compound is that it is a pure substance formed when atoms from different elements combine chemically in fixed ratios to form stable units with different physical and chemical properties. This is an important definition. So I'm going to teach you how to write the formula of some compounds where non-metal atoms forms bonds. First, I'm going to look at the bonds that hydrogen forms. Now, I wrote the atomic number of the hydrogen because that tells us how many electrons the hydrogen atom has, or it's got one electron and it's in group 1, so it's got one valence electron. Then hydrogen, the Lewis structure for hydrogen would have 1 cross, and the number of bonds the hydrogen would form is 1. Now, when one hydrogen atom joins to another hydrogen atom, I can represent the bond by the two hydrogens sharing the two electrons. So we write the two crosses between the two H's to show how hydrogen bonds with another hydrogen. This forms a diatomic element, so two hydrogen atoms combined chemically to form the diatomic element hydrogen. This element is stable because it's got two shared electrons. Next, I want to use fluorine as an example. Now, fluorine has 7 valence electrons. It is in group 17. So when we join fluorine, or when we draw the Lewis structure for fluorine, we have 7 electron crosses around it. Its valency, the number of bonds it forms, is 1. Now my face is in the place for names and formula, so I'm going to write another fluorine atom here instead of in that last column. Now there is one place where fluorine has 1 electron and not 2. So the fluorine atoms come together. Let me do it this way. Fluorine atoms, they come together, and this fluorine atom here will share its electron with the second fluorine atom. So these two electrons are shared between the two atoms. So now the formula for fluorine is F2. And like hydrogen, it is a diatomic element. Right, we're going to move to chlorine now. Chlorine is in the same group as fluorine, so it will also have 7 valence electrons, and the Lewis structure will show the 7 valence electrons like this. its valency is 1, so it can form one bond. So if this chlorine atom comes together with another chlorine atom, the second chlorine atom will also have an electron that is by itself that it would like to share with the first chlorine. So we can redraw this to show the sharing of the electrons taking place there. Now I'd like to discuss why chlorine would want to share the electron, the same reason for fluorine wanting to share electrons. If you look at the noble gases, the first one is helium. It is stable with 2 electrons. Like hydrogen would be stable if it's got 2 electrons, like in the first example we did. All the others, like the neon to the argon, has 8 valence electrons. So when an element has 8 valence electrons, it is stable. So let's look at this chlorine. This chlorine here, when it is sharing the electrons with the second chlorine, it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it will be stable if it's got 8 electrons. If we look at the second chlorine, it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons. So when the element has 8 electrons, valence electrons, then it would be stable. Right, I want to go on to a more complicated element now. The slightly more complicated element is oxygen. It is in group 16, so it's got 6 valence electrons. And we draw the 6 valence electrons like this, 2 together, 2 together, 1 alone and 1 alone. There are 2 places where electrons can be shared to get 2 electrons. So there and there you have place for sharing electrons. Now, place for sharing electrons would mean that bonds are forming there. So there are 2 places. So the valency of oxygen is 2. So it means oxygen can form 2 bonds. So if I take one oxygen and I want to show the bond with a second oxygen, the 1 electron from this oxygen would be shared with 1 electron from that oxygen. Now there is no other way to put it on paper, this sharing of electrons. So I need to put the second set of electrons shared like that. So there are 4 electrons shared in oxygen, and oxygen's formula is O2. Oxygen is also a diatomic gas. Let's look at the number of electrons around this oxygen here. 1, 2, 3, 4, 5, 6, 7, 8. The number of electrons around this oxygen here, 1, 2, 3, 4, 5, 6, 7, 8. So the diatomic oxygen is stable. I want to move to the next more complicated example, and that is nitrogen. Nitrogen is in group 15, so it's got 5 valence electrons. It's got 1 pair of electrons and 3 electrons that are alone. That means that the valency of nitrogen is 3. If I take one nitrogen atom and I want it to form a bond with another nitrogen atom, there are 3 electrons from the one atom that can be shared with 3 electrons from the other atom. So here we go. Sharing of electrons taking place. Oops. And another sharing of electrons taking place. This is the only way we can represent the electrons being shared. So nitrogen is also diatomic because it makes it stable. If we look at this nitrogen here, it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons, even if 6 of them are shared. The second nitrogen, has 1, 2, 3, 4, 5, 6, 7, 8 electrons shared, and the molecule is stable. After what I've said in the previous slides when we discussed the diatomic molecules, I would like just to summarize the following. Monoatomic means that the elements consist of single atoms like the noble gases. They are stable, meaning their valence electron structure, valence energy level is full, while the diatomic elements consist of 2 atoms bonded of the same element bonded chemically, like the hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. They bond because then each atom will think that it's got a stable electron structure.